Hello, everyone, and welcome to another video problem solving session with Special Maths Academy. Please, if you haven't, like this video, subscribe and comment and share with your friends. Okay, so in this video, we'll be looking at the problem 5 from the 2024 Special Maths contest, the first round. And it says, given that u plus v plus w minus uvw all squared plus uv plus vw plus wu minus 1 all squared can be factorized into n non-constant factors. What is the maximum possible value of n? Okay, so let's look at this problem. So something that we can always do when we have questions like this, when we have factorization questions, is we can always play around with the variables to, like, I don't know, get a hint of the structure of the algebraic expression. Especially when the expression is complex. Okay, so if you look at this, so if we set, okay, so if we set W to 0, what does this expression give us? Okay, so let me just call this expression P of U comma V comma W. So we set W to 0. So we have P U V 0 will then become, so this will become U plus V, so that becomes 0 all squared plus, so UV, PW becomes 0, W becomes 0, minus 1 squared. And this, so the good thing about this is that this is a much easier uh, expression to play with, to expand and to factorize back again. So if we do this, what do we have? We get u squared plus v squared plus 2uv, okay, plus uv all squared minus 2uv plus 1, okay? So this is for the second expression. And then we can open the brackets and simplify, but we can immediately see that plus 2uv and minus 2uv will go out. So we have this is equals to u squared plus v squared plus uv all squared plus 1. Okay. And we can factorize this. So we can look at this. So u squared plus, so we can factor out v squared into u squared plus 1 plus 1. So this is equals to, so we have u squared plus 1 plus v squared into u squared plus 1. And this is equal to u squared plus 1 into v squared plus 1. Okay. So this gives us an idea of what this expression should look like. Okay. So my guess from just seeing this is that when we factorize this whole expression, we're going to have something like u squared plus 1 into v squared plus 1 into w squared plus 1. So from seeing this, this is the final factorization that comes to my mind. Okay, but let's see what we can do. So let's go back to the original expression. So I will uh, erase this. Okay, so let's look at the original expression and see if we can get this claim. So P U V W equals to U plus V plus W minus UVW all squared plus UV plus VW plus WU minus 1 all squared. And we can expand this in a way. So this becomes the first bracket. So I think I'll just use big brackets. So this becomes U plus V plus W all squared plus UV W all squared, and then minus 2 into, so I just put UVW to U plus V plus W. Okay. And then the second bracket, so I put a plus here. Second bracket becomes, we have UV plus VW plus WU all squared, and plus 1. So 1 squared is 1, and then minus 2. So 2 times 1 is 1, is 2 rather. And so 2 into UV VW plus WU. So here I'm just using the uh, idea of expanding a binomial expression. So if you have A plus B all squared, this is equal to A squared plus B squared plus 2AB. So that's just the idea I've applied here so far. Okay. Now we can look at, so in the first bracket, we can look at this expression here. So this expression U plus V plus W is going to be equal to U squared plus V squared plus W squared plus 2UV plus 2VW plus 2WU. Okay. So this first expression is going to be this. So it's also the same idea of when you're expanding a trinomial square. So this is quite a popular expression. Now, the second one is where we also need to do this, but then we do some algebraic manipulation at the end. So UV plus VW plus WU all squared. So sorry, this should be all squared. So this is going to be equal to, so we have UV squared plus VW squared plus WU squared plus, so we have 2, we'll take the first two, so 2 UV VW plus 2 VW WU plus 2 WU into UV. Okay. So this second expression is equal to, so we can just factor this out. So we have U squared V squared plus V squared W squared plus W squared U squared plus. So this is where the algebraic manipulation comes in. So we can see that from this second term, 2 is a common factor and UVW is a common factor as well. So this becomes into U plus V plus W. Okay. And now we can apply this here. Okay. So this implies that P U V W, so this is going to be equal to, so we have U squared plus W squared plus V squared plus, so we have 2 into UV plus VW plus WU. Okay. Then we have plus UVW all squared minus 2UVW into U plus V plus W. Okay. Plus, so this term here becomes U squared V squared plus V squared W squared plus W squared U squared plus 2UVW into U plus V plus W, and then plus 1, and then minus 2 into UV plus VW plus WU. Okay. So now looking at this, we can see immediately that some things will cancel out. Okay, so we have minus 2UVW into U plus V plus W here, and then we have plus 2UVW into U plus V plus W here. So these two go. Then also we have minus 2 into UV plus VW plus WU here, and here we have plus 2 into UV plus VW plus WU here. So those two go. So in essence, this implies that P, U, P, W, the expression becomes, so I can remove those big square brackets. So plus V squared, and then plus, so we have U squared, V squared, W squared, that's this. And then we have plus U squared, V squared, plus V squared, W squared, plus W squared, U squared, and then we have plus 1. Okay, so let's scroll down a bit. So now we can take some time. So recall that we had when we said when we said v equals 0, we had this term. So let me use a different color. We had U squared, W squared. Okay, so I think it was when we said W equals 0, we had U squared, V squared, uh, U squared, V squared. No, not this one. U squared, V squared, and then we had 1. Okay, so we can take those ones together, and then we look at the other ones left. So we have this is equals to, so we have U squared plus V squared plus U squared V squared plus 1. Okay, and then we have plus W squared plus U squared V squared W squared plus V squared W squared plus W squared U squared. Okay, yeah, so we have this. So let's scroll up a bit, and then let's factorize. So recall that we already know how to factorize this first part. So this becomes U squared plus 1 and V squared plus 1. Okay, and then here we have we can factor W squared first of all. That's a common term. So we have W squared into 1 plus U squared V squared plus V squared plus U squared. And then we have this again, which we already not factorize. So this is going to be equal to uh, U squared plus 1 into V squared plus 1, and then plus W squared into U squared plus 1, and plus and into V squared plus 1. Okay, so here we have this term and this term, common terms. So we can scroll down a bit again, and then this gives us that. So we can factor this out. So we have U squared plus 1 into V squared plus 1. What do we have in the brackets? We have 1 plus W squared, because when we take U squared plus 1 into V squared plus 1 from the first term, we have 1. And then from second term, we have just W squared left. So that's the same thing as W squared plus 1. And so this is the final factorization, which I had earlier claimed. So I made an educated guess, so it was not a random guess. Okay, so now we have this, we've shown that this is the final form. So how do we know that this cannot be factorized further? So how we know this cannot be factorized further is we can, so first of all, each of these terms are non-constant, so they satisfy this. Now, how we know that this has to be the maximum? Because we can select values of u, v, and w such that each of these terms become a prime. Okay, so for instance, uh, we can set u equals 2, okay, and v equals 4, and can set w, so you can set w to be equal to 6, okay? So that will become, so u squared plus 1, so 4 plus 1, so that will be 5 times, so 4 squared plus 1, so that's 16 plus 1, so 17, and 6 squared plus 1, that's 36 plus 1, that's 37. So this should be times rather. So, so 5 times 17 times 37. And we see that 5 times 17 times 37, we can't factorize it any further. So it's just 3. So basically the answer is D, which is 3. I hope you enjoyed the video. Feel free to like, share, comment, subscribe, all that good stuff. And we'll see you on Friday. Have a wonderful day and goodbye.